Good afternoon, everyone. Thank you. It's a bit shit when you get the afternoon thing, because you guys either had lunch or didn't have lunch, but everyone's waning a bit. And I'm not here to sell anything, and I'm old enough in the tooth to have a lot of opinions. So hopefully there'll be something that provokes you into action at the end, and I'll run around with the microphone and force you to ask questions. So, yeah, I'm talking about this thing called spatial collaboration at the speed of light. But I'm going to show you something that's kind of not connected with that first, but is. I'll do this. Possibly. Yeah, there we go. So what the hell has this got to do with collaboration? Quite a lot, even to do with virtual environments. And I think it's really interesting when I come to these conferences that we use this word VR, but of course then we use XR. But what we often forget is that the focus is not on the headset. You know, we tend to think, oh, virtual reality means a headset, augmented reality means a see-through headset, or mixed reality, or a handheld. But actually, virtual environments are one of the key things that drives this, the ability to create content that sits in a virtual world, which doesn't even have to be accessed through a headset. And sometimes it can be accessed through an LED wall, like in virtual production, or on a projection screen, or other ways of visualizing this content. A headset or a handset isn't always the most appropriate way to do it. And often it's a mixture of different devices for different people accessing that content, whether it's purely virtual or whether it's, you know, mixed reality or somehow connected with the real world. Now, oh, it's gone. Let's see if we... So this project, I have a long background as a serial entrepreneur. I won't go into that, but I lived in the States in the 90s. And in 1993, I was working with Boeing, developing simulation systems for their first fly-by-wire aircraft. And I got an invite to the Human Interface Technology Lab. Some of you might know a guy called Jacobson, who was heavily involved there, or you may not. But one of the things they were developing, apart from early applications of VR for medical treatment like burns, trauma, and social disorders, was a retinal projection device. And I remember one evening in 92, 93, sitting down at a huge optics workbench with my head in a cradle, having a laser put directly into my retina, and seeing about 20 polygons, beautifully crisp and moving around, and no glasses. No glasses at all. And I moved my head back a little bit from this amazing experience, and there was a tunnel, and the tunnel was the pupil in my eye. I could actually get a feeling of looking through a tunnel to the laser with this developed in the back. And moving on a few years from that to about 2000, I was speaking with some guys from Nokia who said, all our phones will have GPS next year. Well, it wasn't till about 2007 and so on that most phones started having GPS. So I put all this stuff together about, you know, these guys are going to make really lightweight retinal projection, augmented reality glasses, handsets are going to have GPS in. And I took some of my well-earned money from other startups and started a startup in Berlin in 2001 to make massively multiplayer, location-based augmented reality games. I was a bit too early. And also the dot-com bubble crashed the following year, so money died up. Niantic, of course, started doing some of this stuff with Pokemon Go, and we are still a long way off from having really decent headsets that the consumers are going to use for these sorts of applications. Of course, thanks to NVIDIA and the gaming market, we have high-performance, low-cost GPUs. We have a lot of hardware that's getting there. So for many applications, we have things that are usable. But I think the really interesting stuff is still going to happen in the next 5 or even 10 years. So that's not a downer. A lot of stuff can happen now. So what's this? So when I'm not doing research and doing entrepreneurial stuff, which is on a sabbatical at the moment, 10 years ago I started an arts practice. And in that arts practice, I increasingly started using Unity and Unreal Engine to create virtual worlds that did networked, network co-location. And so I build projects in my art studio and work with orchestras and theater companies and other people. And long before COVID, we built environments that link. In this case, there is a performer in London playing the Glockenspiel. The actor in the front, which you can't see, who was dancing, is in Barcelona, and the girl behind is in Copenhagen. And this is a view into a set where there are low latency video streams coming in from 2 other locations. The performers are all working together. The projection is onto a thing in the theater industry we call a scrim. It's like a very fine fishnet. And basically for me, this is virtual mixed reality. We're using Unity in this case to pull these components together. So this doesn't need headsets. It's a theatrical performance that's using virtual environments, low latency networks, and distributed collaboration. So I took a lot of experience in my arts practice, and 3 years ago, I was invited to set up a lab at Design Academy Eindhoven, which apparently is considered one of the top 10 design schools in the world. I don't really know. It's an interesting place. So now we have about 1,000 square meter lab there, and I have about 25 people working on different, mostly EU and some Dutch-funded programs. And all of those programs are looking around how we pull disparate technologies together to create what I call distributed, spatially networked immersive environments for collaboration. So rather than kind of the low-level handset stuff, we're mostly using Unreal, sometimes Unity, motion capture systems, and other things to prototype what I think will be achievable in a few years from now with the next levels of commercial hardware. So there's also a little bit of a lie. Oops, sorry. There we go. Yeah. I got this new habit a few months ago of because I'm lazy sometimes or I'm too busy, of getting AI to generate images, and they're damn awful, really. I mean, after several attempts, this is the best image I could get, which supposedly demonstrates spatial collaboration at the speed of light. Well, I'll get into a bit of engineering stuff as well, because I'm also an engineer. So the speed of light, we don't really communicate at the speed of light. Probably most of you know that data propagates in a fiber optic cable at 2/3 the speed of light. So that's around 200 kilometers a millisecond. These numbers are really important when you want to build continent or global systems. When you see Mark Zuckerberg apparently playing ping pong tennis in Meta Horizons, nothing against Meta, with someone in California and Australia, it's not possible. The round-trip latency is too high to play ping pong. So it's faked, which is fine if you're in the entertainment market. If you want to do things like telesurgery, real-time engineering collaboration and so on, or in fact classical music where musicians can't play more than 50 milliseconds apart, which limits musical performances to much smaller distances, then you really need to understand the network layer in this. And also don't listen to the mobile guys who tell you everything's going to be wireless in the future. It isn't. Wireless will increasingly be a shorter and shorter distance for delivery, and we will use more and more fiber because we need huge amounts of bandwidth to do immersive collaboration at a distance. I'm happy if anyone wants to disagree with me on any of my perspectives at the end. So I have this thing called an intraverse, because I don't think there is really one metaverse. There is hopefully one set of metaverse standards or a collection of metaverse standards, but I think just as we employ, or industry employs the intranet today, we will see intraverses, which are mini self-contained metaverses, which are for security reasons or practicality reasons in specific areas. I have very few bullet points elsewhere. So I think these are in things like manufacturing, design collaboration, healthcare, education, those sorts of areas. I think whereas the consumer metaverse at this point is primarily low fidelity, it's cloud streamed, it's browser based, it seems to be real time. Real time is always contextual depending on your application, but most of the time it's faked. Even in Fortnite, there are many mechanisms so that when two people chop down the same tree, the server decides who actually chopped it down first, not necessarily based on who thought or actually did chop it down first. But in the industrial world or commercial world, you need to really think about time. So I think intraverses are more high fidelity, so we're typically using Unreal Unity and not lower-end engines or handsets. The architectures are not cloud or edge. This is another misnomer if you hear this. The future is a mixture of all of these things. So systems will be replicated, they will be cloud-based, they will be at the edge, or even in what we sometimes call the fog or the mist. We need things that are contextually real-time. So depending on your application, latency is different, critical to what you're doing. And I think we will have realistic metahumans. Avatars, people with orange hair, pink beards, 3 legs, fine in the social world. In the business world, for industrial applications, I think we will increasingly see avatars that look like you and me, because that's who I recognize. You know, when I see you or you in a virtual environment collaborating about designing a jet engine, I don't need to see, I know, Spock or Shakespeare or something. I want to see something that looks like you. And I also don't think that will be through volumetric rendering. It will be through AI-based motion capture and stored avatars because they have a lot lower latency. So just to wrap up, I think the standards bit is important. Hopefully some of you have heard of the Metaverse Standards Forum. You can rule out the word metaverse or not. It was funded by Epic Games and a bunch of other people in the States, Niantic and those guys are there. But also there's a lot of European collaboration. There's IEEE Metaverse Standards, Kronos, blah, 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 blah. But at least there is standards activity, and I think that it's great to see people like Snap, Niantic and so on building new markets around new technologies, but they're all closed stores, just as Roblox and Fortnite is. And we need things that break out of that if we're really going to generate bigger markets. So just a couple of quick examples. And they're terrible AI images as well. But let's imagine we're in engineering maintenance, that we have someone in a shipyard. I love how AI makes the mistake. I ask for a prop engine for a ship, and it gives me a ship engine with an aircraft propeller on it. I love this stuff. But let's say we have a drawing office, we have someone in a manufacturing facility or in a shipyard and someone in the engine bay. We need ways that these guys can actually pull up drawings, look at physical parts of an engine, augmented parts, and collaborate as if they're in the same room, even if they're 1,000 kilometers apart. And in the medical world, we already started working in some research in this area. You can also spot the mistake in one image here. I asked AI for a crash scene, which it actually quite beautifully generated, but unfortunately most of the people that are victims in the crash scene are fire and ambulance workers, because AI doesn't know that when these guys turn up, they aren't also the victims. But anyway, and so we have often a crash scene needs more than the medics. It needs doctors and surgeons who can be at the scene. So we need things like super low latency, very close to real-time Gaussian splat built environments where we scan a remote environment and a surgeon in a hospital can actually enter that environment from the hospital and work on the scene as if he's there to help medics. There are thousands of applications like this which are not the ones that often we're hearing about, which are, like the Snapchat and Meta Horizons and all this sort of thing. And it's mostly a matter of integrating technologies. Often the technologies are there. So in our lab, we're investigating ways or challenges about how we build systems to prototype these. Not really from a commercial output, although some of the projects we're working on will produce basically industry-ready software. So we did a project, one of the first projects in this area, only 2.5 years ago. And if you know these guys, they're actually from Digital Domain, which is, I think, one of the top 5 or 6 special effects companies in Hollywood. This is a digital human with their own rendering engine running in Unreal. The guy on the right is Marcus, he's a German. He's the real guy, the other guy is the metahuman. And we built an Unreal environment where we streamed their Unreal environment into our Unreal environment across the Atlantic, across the States, across the Atlantic. They could basically interact in our Unreal space. And we also did collaborations with ZRDK, which is in Zurich, and also the Bartlett School of Architecture in London. So this was all about how we linked instances of Unreal, and also in one case Unity, in different locations to blend interaction and also motion capture from those. And all these things took lots of coding in C++, custom blueprints, C#, whatever, to do that. We did a project funded by SURF, which is the Dutch national, each country has its own educational internet. So they funded us on a project, not a great shot. And we were looking initially at using multi-user editing in Unreal, and we were looking at how we could do real-time collaboration at a distance. And then we did a little project where we had people in Xsens suits. Xsens is an inside-out motion capture system, if you're not familiar with it. And they were in 2 different locations, and they both appeared as metahumans in a maze, and they could edit and walk around that maze, and the round-trip time over about 200 kilometers was about 10 milliseconds. So they were acting completely naturally in a shared virtual environment, relatively high fidelity, though it's not a great image there. So on from this, we have a European project called Hybrid Lab, where we have built digital twins of a couple of real locations in Europe. One, the high-tech campus in Eindhoven, and another one being part of the University of Kiel. And in this, we are testing how manufacturers, designers, stakeholders, and planners can collaborate in very realistic, animated, interactive digital twins. In this project, we have the customer, who's down there on the right in the high-tech campus, 2 companies that work with 3D printers and recycled plastic to make furniture and workplaces for the environment. And in this scenario, the customer is inside the digital twin at their home location, wearing a headset, and also can be an XN suit if they want to accurately position themselves. And the designers are working with parametric design tools. They talk in real time, and the customer can say things like, yeah, I want this over here a bit, I want a different color. And the updates are typically in about 150 to 200 milliseconds. So for me, these are kind of real-world applications of spatial collaboration at a distance or an intraverse. You can just see a few shots. Here, this is part of our lab. We were using Zoom as a back channel, and here you can see someone actually in part of the digital twin. This was, I think, about 9 months ago. It's moved on from that now. So, and we have animated cars, and you can set like it's winter, so there's no leaves on the tree, and it's not sunrise till 8. So that's the beauty of using, high-end games engines for building digital twins, rather than just rendering them. I just show this quickly. It's a bit Instagram-y, but it's cheesy at the end. But of course, the idea is that not necessarily we travel less, but we get more contact time. Yeah. I thought I had tons of time today, and I'm already running out. That's normal. So we have another project funded by the European Union, where we're working with the University of Aalto and the Film Academy Baden-Württemberg. How many of you guys know what virtual production is? A few. It's the stuff like Mandalorian, where they use a big LED wall and they use a game engine, and that generates the scenography in real time. So all of these projects, we've been developing a lot of custom code. It's actually a real pain in the ass to network multiple instances of Unreal or Unity in different locations, because people have firewalls and all sorts of crappy networks in between, and everything's on different subnets if you're a networking person. So we're building a software and systems framework funded by our friends at the EU, which allow us to solve some of these problems of, let's say you have a mocap system, a games engine, HMDs, and other things at 2 locations, and you want to connect them together so they act as one co-located, distributed virtual environment platform. It's very hard to do that. And you can talk to me later about more details, but there's just all sorts of crap in networking. So you end up spending a lot of, when you want to run an experiment or a use case, it takes a lot of time to set it up. So basically, getting a bit techy, we're building a distributed node JavaScript-based system with plugins and clients that work with things like EtSense and OptiTrack and Unreal and Unity, which allows us to make a framework which runs over a secure, transparent VPN, so it breaks through all the firewalls, and it makes all those systems act as though they're in one location, so you can focus on doing things like virtual production or other experiments. I don't think I'll go into this level of detail, but basically you can see we have this back-end server, we have a user interface, we have clients that fit with Unreal. We're going to release this on GitHub about March or April next year, so the original release, and it's developed to what we call TRL8, which is basically one step away from commercial-grade software. So I have a full professional software development team, even though we're working out of a lab. I won't go through this use case, I can share it later, but this shows how, rather than setting up lots of stuff when you want to get mocap into Unreal, you just basically use our user interface. It's a packaged version at the moment. So you can see we have a web front end, and with that you can pull up objects for Unreal, for OptiTrack, and it doesn't matter if Unreal is in Copenhagen and the OptiTrack or XSense system is in Austria. When you drag a link from one to the other, it automatically enables a stream of motion capture data going from one location to the other location. And we're going to be using this in a test case. It's the last thing I want to say. Yeah. And if anyone knows who this is a sketch of, I won't tell you. It's Erwin Schrödinger. And Schrodinger, you probably heard of Schrodinger's cat and the cat stuck in the fridge and these things. So next year is the International Year of the Quantum, curiously enough. So we are making a film in what we call a distributed virtual production environment about quantum entanglement. You can ask me later if you want to get into particle physics. But basically, we will have 3 locations with replicated instances, about 10 instances of Unreal. We have actors in 3 different locations, some in OptiTrack, some in XSense, and they're wearing headsets, probably be a Quest Pro because of facial capture, but they will all see each other as their animated characters in real time, within about 20 milliseconds, which is real time enough, in the virtual environment, and the virtual camera and audio people are also in different locations. So basically, we make a virtual production film set that crosses 3 countries, that works in real time, and that's powered by the software that we've been developing, which is called XRIT. So I'll shut up. I can always talk about more things. I would love to hear some questions about any of the points I raised.
Thank you very, very much. Come on, let's give a round of applause. So, we do have time for a couple of questions. So,
someone must disagree with something I said at least.
Could you just outline the limits for that tag? Where's the limit for that in space? Like how far apart you can put people?
You mean space?
Yes.
Space.
Well, that's one of the use cases, what I'm thinking of, but yeah.
Sorry, I have terrible audio here, but...
The question is, how far
I just come down, you can tell me.
But for the others, how far apart can be the people? Like in 200 kilometers, 2,000?
No, it's not too far.
Yeah,
I mean, how far apart can they be to interact in real time?
Yes, where is that limit?
Okay, it depends on the context. So human speech is really great, because if we're talking to each other and I go, yeah, okay. You have quite big gaps, so 200, 300, 400 milliseconds. If you're doing human movements and passing things to each other, perhaps 150, 200 milliseconds. If you're playing ping pong tennis, as I said, it doesn't really work. If you want to do classical music performances, it doesn't work because the audio just can't be streamed that fast. So again, different applications work in different ways. But within the same continent, you can do, even between here and the States, you can do most of these kind of film-type projects on the network.
Yes, I also had a question about real time, because I'm sorry. My question is also about real time. I think there's only very limited information which really has to go down in real time. The other thing can also have a latency. So
if you're playing games, you can get away with a lot because you fudge it. And that's what happens in the games world. Things are fixed, you think they're real time, but they're not really in real time. If you want to do things like surgery or engineering, you need closer to real time. But really, real time is a misunderstood word. You know, I see mobile operators saying with 6G, it will be 1 millisecond response time. But they forget to mention over what distance. Distance is always a really critical thing. So never believe half this stuff that people are pushing about latencies or real time. You really have to dig below and ask in what use case, at what distance, in what application. Actually, it's the reason in most of these use cases that we've gone for replicated instances rather than cloud-based. Because if you're doing things in motion capture, if you're doing things with gloves and stuff like that, you want really local to the computer. And then you only stream the motion capture data to all the other instances from all the other instances, so everyone gets the best local response time, but you also then use low latency networks and tricks to get the other data between the clients directly, which is why cloud-based computing, cloud-based architectures often do not work if you want the best real-time experience, especially in industrial-type applications.
I think we have time for one more question.
We'll make it easy then. What was the biggest challenge you ran into so far integrating all these systems together? And what was the biggest benefit so far that you found as part of that process?
There's always challenges. It's software and systems development. So I think something every day. Actually, number one, getting people. There's a huge shortage of people in the industry. You try and any C++ Unreal programmers here that want a job? Oh, okay, see me afterwards, thanks. Advantages is how quickly we can build new structures now. So when we want to network different labs or different industrial partners, we deploy the client, and now we can set up test cases within 30 minutes and get going, whereas before it took 2 or 3 days of like talking with the network guys and so on. So huge advantages in testing out and prototyping new scenarios. Okay. Thanks.
Yeah, thank you very much. Thank you very much. So let's give another round of applause.